Okay, we're looking at question number 5. You would like to make a salad that consists of lettuce, tomato, cucumber, and radishes. You go to the supermarket intending to purchase one variety of these ingredients. You discover that there are 8 varieties of lettuce, 5 varieties of tomatoes, 3 varieties of cucumbers, and 4 varieties of radishes. So it says, how many different salads can you make? Well, this is where we use what is called the fundamental counting rule. And the fundamental counting rule says that I can multiply all my different options together to get the total amount of different ways I can have a salad. So, first of all, we had, let's try this. So we had 8 different types of lettuces times 5 different types of tomatoes times, 3 different types of cucumbers times 4 different types of radishes. So if we multiply all of those together, that would be 480 different varieties of salads. Now, you could have sat and tried to write all of these out, but it would have taken you a long time to get those. All right, let me see if I can return back to my screen. Okay, there we go. Alright, so the answer would be 480 different types of salad. Okay, on the next question it says, in a race with 12 swimmers, how many different orders of finish are possible for the first 4 positions? Now here, the order matters, because a swimmer who finishing first is going to be different if that same swimmer finished third or fourth. So the order does matter, so we are going to use the formula for permutations. We have 12 swimmers, and how many different finishes can we have with 4 positions? So let's look at this. This is going to be a permutation, so we have NPX, where N was 12 and X was 4. So we know that that's going to be 12 factorial over 12 minus 4 factorial. So 12 minus 4 would be 8. So we're going to get 12 times 10 times 9 times 8. And then we have 8. So we do 12 times 10. I always leave out 11. I don't know why I did that earlier. 12 times 11 times 10 times 9. And let me go back and see what we got there. When you multiply that out, you get 11,880 there. For the next one, we have a panel of 11 jurors needs to be selected from a group of 60 people. How many different juries can be selected? Now, when you're trying to select a group, the order doesn't matter. Think about it. When you're selecting your starting players, it does not matter whose name's announced first. It's those particular starters. So here the order doesn't matter, so we will use a combination. So we will do, let me go back. We have 60 jurors and we need 11. So we will have 60 factorial over 60 minus 11 factorial over 11 factorial. Okay, so when I did this one, of course I don't want to say 60 times 59 times 58 times 57 all the way to 49. So the way that I did this one, I used my phone, and on the phone it looks like this, x factorial. If you have an iPhone, it looks like that. So what I did was, I put in, and I'll do it right now just to make sure that I can explain it correctly. I did 60, and then I pressed the x factorial button, and you're going to get 8.32 something something exponent 81 because it's a huge number. Then hit divided by 49 x factorial. And when you do that, you should get 6.08 long number exponential or exponent 62. And then divided by 11 x factorial. And then let me go back to my, and then press equals, and you will get, so don't press equal until the end, you will get the big number there, 342,700,125,300. Okay, I skipped 2. I will go back to those and work them on a different video. There are 4 teams in a division of professional sports league. How many different ways can the 4 teams finish at the end of the season in the standings? So, of course, the order does matter here. A team that finishes first is not the same as that same team finishing second. So the order does matter. It is a permutation. But we don't have a combination or anything like, we just have the number 4. So to do a permutation with just the number 4, all you're going to do is you're going to do 4 times 3 times 2 times 1, just 4 factorial. So that would be 24 would be the total number of ways you would finish. Okay, for number 11, an event planner decides to do a seating arrangement for 7 people at a table. Calculate the number of possible arrangements from which to choose. Okay, well, seating arrangement, the order is going to matter because where I'm sitting at, the order that I'm sitting at a table is going to change if even if it's the same group of people, the chair that I'm sitting in, the order is going to change. So the order does matter here. Okay. So I'm going to, when the order matters, remember I'm going to do a permutation, and this is just like, basically just like the one we just did. You would do 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, or just do 7 and then press the X factorial button on your iPhone, or use the factorial button on your calculator. Okay, and then for number 12, a research study needs to select 2 people to participate from a group of 6. Calculate the total number of unique groups that can be formed. So we're picking a group, kind of like we're picking the starting lineup for a team. The order's not really important, okay? It's a group of 2 people anyway. So what I'm going to do is, let's see if I can do this, if I can remember what the numbers were. I believe it was, 6 people, and we're picking groups of 2, and the order doesn't matter. So you're going to have 6 factorial over 6 minus 2 factorial over 2 factorial. So 6 minus 2 is 4 factorial. So we'll have 6 times 5 times 4 factorial over 4 factorial times 2 factorial. The factorials cancel out and you end up with 30 divided by 2, which is 15. So there are 15 unique groups that could be formed here. Okay, 16 members of a group of 18 are to be selected for a team. how many ways are there to select these 16 members? So 16 members of a group of 18 are to be selected for a team. So this is basically the order does not matter. So I can do 16. Oh, didn't mean to do that. 16 combination of 2. So I end up with 16. I hope I got the right numbers because I did not write this one down. So let's bear with me for a second. I may have to just, let me go back for a second. Okay, 16 members of a group of 18. I knew I had a number wrong. So let's go back to that. So we have 18 combination of 16. So we have 18 factorial over 18 minus 16 factorial over 16 factorial. So you end up with 18 times 17 times, I'm going to stop at 16 because I know I'm going to have a 16 on the bottom to cancel it out with. Okay, so I end up with 18 times 17 divided by 2. And that would give you 153 ways. And then determine the ways of which 6 men and 6 women can be selected from a group of 12 men and 12 women. So this one is where you're going to select, you're going to do one for the men and one for the women, and the order does not matter. So remember, if the order does not matter, that we're going to use a combination. And once we get those two numbers, then we're going to multiply those two numbers together. I think I worked this somewhere. Not quite sure where I worked it. So I'm going to okay, I'm going to try to, well, I'm going to run out of time. So do, what you need to do is 6, let's see, we have 6 men and 6 women from a group of 12 men. So your first one would be 12 combination 6 and then 13 combination 6. Get those two, get the one for the men and one for the women, and then you multiply it together. I didn't want to start that and run out of time. So this should get you through 4.3 except for those 2 problems that I didn't work, and I'm going to go back and do another video on those.